Good morning, Year 5. Welcome to your Wednesday maths lesson. You've got your 4 mental maths questions on the screen there. Not forgetting you've got a shape in the right-hand corner, 2D shape today. So give yourself 30 seconds, pause the video, and then we'll go through the answers. Pause now. Question number 1. Add 0.45 to 0.85. If I add these two values together, I would get the value 1.3 or 1.30. Question 2. What is 0.05 or 5 hundredths less than 0.71, which is 71 hundredths? 71 hundredths subtract 5 hundredths would give me 66 hundredths. So the decimal 0.66. Question 3. What percentage is the same as 3/5? 1/5 from our equivalence lesson a few days ago we said was 20%, 2/5, 40%, 3/5, 60%. So you hopefully wrote down or circled 60%. How many sides does a hexagon have? A hexagon has 6 sides, and the shape here in the right hand corner is a rectangle. We know it is. It's got lines on opposite sides, which mean that the sides are of equal length, and we know that one property of a rectangle is that opposite sides are equal. So a rectangle is what I was looking for that one. Let's start today's lesson. As our walk tells us, we are going to learn about addition once more with decimals, but today we're going to be looking at adding decimals with a different number of decimal places, which means that the numbers have a different number of digits after the decimal point. We'll start off with a nice and simple example. If I was to do 2.5 add 3.16, I'm hoping that straight away a number of you are thinking I could work that out mentally. If you're thinking that, that's great, because that's what I was hoping you would say. Just to be clear and make sure that we are spot on, what I'm talking about with the number of decimal places, can you see 2.5 is a number with ones and tenths. 3.16 is a number with ones, tenths, and hundredths. So this number has got 2 digits appearing after the decimal point. This number only has the 1 digit. But as we know, because we've got a blank space here, we could just add a 0 to that to mean that they both have the same number of equal decimal. They're both written to the same number of decimal places. Looking at it there then, so 0 hundredths add 6 hundredths in total. I've got 6 hundredths, which I've got represented on my place value grid as well. 5 tenths add 1 tenth is 6 tenths, as we can see represented pictorially here. And 3 ones add 2 ones is 5 ones, which again is represented nice and clearly using our place value grid. Just before we move on, look closely at the column method here that I've written out. Notice how I have lined up my decimal points. The decimal points, when using addition or subtraction or any of the 4 operations, doesn't move. The decimal point always appears between the ones column and the tenths column. The decimal point never moves. Whenever you're using a formal method of adding decimals together, you are always looking to line your decimal points up, putting your decimal points in and then writing your number around it. I can't stress how important that is. The decimal point doesn't move. Let's have a look at a second example. That one was quite a straightforward one to get us going. Let's move these out of the way and just practice that example, thinking about what I've just said there. If you've got a pen and paper or a pencil and a bit of paper to hand or a whiteboard, you're going to need it. So if you have got it, get it ready, because in a moment I'm going to ask you to take a look at these two calculations. I'm going to ask you in a minute to pause the video. think about what I've just said about lining up the digits and lining up the decimal points. I am going to ask you to add these two together. So you've got 32.8 and 1.17, and you've also got 534 add 5.34. Just before you do pause the video, just a little clue for this question here. 534 is the same as 534.0. So that will help you work out where your digits go and how to line your decimal points up with your second number. So pause the video now and have a go at adding these two numbers together and then these two numbers together. Let's have a look at the solutions then. So 32.8, written like so. Put my decimal point in and then I can write my 1.17 around that. Remember what I said? The decimal point never moves. So always put it in and then write your numbers around it like I've just done there with the 1.17. Then you're not tempted to move the decimal points or mistakenly put one number under the other if they're not quite lined up. 0 add 7, so 0 hundredths add 7 hundredths is 7 hundredths. 8 tenths add 1 tenth is 9 tenths. 2 ones add 1 one is 3 ones. And 3 tens add 0 tens is 3 tens. 33.97. Tick for us, tick for you if you got it right, well done. Second example, 534 I said was the same as 534.0. Because I put the point 0 in, I can then line my second number up by putting my decimal point in first and then writing the 5.34 around it, like so. Put my decimal point in my answer, put my addition symbol in so I know that I'm adding. 0 hundredths add 4 hundredths is 4 hundredths. 0 tenths add 3 tenths is 3 tenths. 5 ones add 4 ones is 9 ones. 3 tens add 0 tens is 3 tens. And 5 hundredths add 0 hundredths is 5 hundredths. 539.34. So lining decimal points up is crucial when adding or subtracting or using any of the 4 operations involving decimals. It's really, really important. You have got on your worksheet today 7 questions which will allow you to practice that skill. So the first 7 questions will help you consolidate what I've just said there. Moving on to the other questions on the worksheet though, you're going to have a look at something like this today. So I'm going to do a calculation with some missing digits in. So I'm going to do something 5.3, addition again, we're doing adding today again, 1 something point something 7. So where the boxes are the missing digits, which we've got to try and work out. The answer, which is shown at the bottom of the place value grid, I'm going to write it into my column addition as well, is 25.67. Now, looking at my place value grid, I can see 0 hundredths add 7 hundredths is 7 hundredths. So I've got a total of 7 hundredths in this column. I don't need to add any other further counters to this box here to give me my total of 7. So this here can remain a 0. Look at my 10th column. I've got 3 tenths in my first number, as I can see here on my column, and here in my tenths of my place value grid. I need to work out I've got 3/10 here, but in total I need to end up with 6/10. So I need to add something to get me to 6/10. What do I add to 3/10 to get to 6/10? I add a further 3, which I'm going to represent using counters here. I'm also going to represent using the digit 3 here. So far, so good. My tenths and my hundredths both add up now to my given value of my answer. Let's look at the ones column. I've got 5 ones here represented in my place value grid and in my column method. 5 add 0 or add something gives me 5. What do I add to 5 to get to 5? I add 0. So this missing digit here is also a 0. Don't need to add any further counters because I've already got my total number in my answer written in my first number. So that's fine. Finally, something add 1/10 gives me 2 10s. So I need to add 1 further 10 to give me my answer, and I need to put that missing digit in here like so. So I've worked out that 15.3 add 10.37 gives me 25.67. Nice and straightforward, hopefully. Let's try and make it a little bit trickier. Same sort of thing, but I'm going to make our lives a little bit harder now. Let's get rid of all of this and write my second example down. My second example is going to be, let's have a look, 1 something 0.04 and 25.1 something. Put my addition symbol in, draw my lines, and I'm going to put the answer as 41.16. Once again, I'll represent that using counters on my place value grid. So let's have a look again. And this is going to be a bit trickier, so listen carefully because it's going to get a little bit more complicated. So I've started by representing my digits that I know from here in my place value grid. So I've got my 110. I don't know how many ones here. Don't know how many hundredths here. But all my other numbers have been represented using counters. And my answer is here at the bottom. So let's start by looking at the lowest value column, as we always do. In this case, it's the hundredths column. So I have 4 hundredths in my first number. I have a total of 6 hundredths in my answer. So I need to work out what do I add to 4 hundredths to get to 6 hundredths. I need to add a further 2 counters, like so. And I can put my missing digit in my calculation like that. 4 add 2 is 6. 400 add 200 is 600. So far, so good. It's not getting very complicated, Mr. Mills, I hear you say. Just we wait. Next column, 10th column. I have 0 tenths, add my 1/10 gives me 1/10. I've got all the digits I need in my 10th column. I've got no missing values, so we're absolutely fine. You can see that the total number of tenths I have is 1. So we're okay. Still not getting very tricky. Well, let's have a look at the next column then. So the ones column. So at first, it might be slightly confusing because you might be thinking, how can 5 ones, which I've got written here and I've got represented here, add something to give me 1, which is what I've got, 1 in my 1 column. What helps here is looking at the tens place, the next highest value column. Both of my tens digits are given. I've got a 2 here and I've got a 1 here. So I've got both of my tens, but the total is 4. And we know that 2 add 1 isn't 4. So The total ones, if I go back to my ones column, needs to be more than 10. Because if it's 10 or more, you know, if it's 10 or more, we do an exchange. So I need to be able to do an exchange to give me an extra 10 to mean that my tens columns add up correctly. I, at the moment, have 5 ones. To be left with 1 1, I need to add a further 6 ones. So I'm going to put my 6 counters into here like so. Why on earth do I need to be left with 1 1, you might be thinking? Well, look at the digit in the ones column. I still end up with a 1 here, don't I? Still end up with a 1. So I need to have 1 remaining once I've exchanged. Now, because in total I have got 11 ones, I can do an exchange. 10 or more we can exchange from what we've looked at in previous lessons. Hopefully you've remembered that. So I can exchange 10 of my ones. So if I get my pen and I'm just going to highlight this, I can exchange 10 of my ones, which are these 10 here. I can exchange 10 of my ones for 1 10. So those 10 ones have the same value as one of these 10s here. Now to show that on my in my column method, what did I add to the 5 to give me 11? We added a further 6 counters, so that can go in here. I then exchanged 10 of those ones for 1 10 by putting the 1 here. Now if I look, 1 add 2, add my exchange 1, gives me the correct total. So actually, 16.04 add 25.12 gives me my answer of 41.16. There we have it. So that was quite tricky, and it was definitely a lot trickier than the first missing digit example that we looked at. But missing digit calculations are very, very popular when it's looking at decimals. Even when we're not looking at decimals, you'll always come across some kind of missing digit calculation because it's a good way of testing, do you understand not just purely how to add numbers, which you will practice in the first 7 questions, but can you apply your thinking? You know, we always talk about reasoning and problem solving. This is kind of that, isn't it? You've got to have to think outside the box almost and really think hard about what it is that you know and what you can infer. What can you learn from what you know to apply it to your problem and get your final answer? So keep an eye out for some missing digit calculations today. That's it from me. I'm going to leave the lesson there. I'm going to let you crack on with your worksheets now. So adding decimals with different numbers of decimal places. Remember, line the decimal points up. It never moves. The decimal point never moves. It doesn't move in year 5, year 6, year 7, year 10. It doesn't move. So whenever you're doing additions using decimals, different number of decimal places, always line them up and work from there. I think that's pretty clear. I think you kind of know that I'm insisting on that now. I'm going to let you crack on and go for it. All right, enjoy your learning, and I'll see you tomorrow.